Okay, we're looking at chemical equilibrium here. I'm going to create a concept map on this piece of paper here to describe all of Unit 3, I believe it is, Unit 3, Topic 1. Okay, so we're looking at chemical equilibrium, Eqbm for equilibrium. Okay, so Unit 3, Topic 1. And so when we're talking about chemical equilibrium, we're talking about chemical systems. Okay, they could be phase changes, physical changes, or chemical reactions. So a chemical system can be open or it can be closed. Okay, now if it is open, we get exchange of matter and energy with the surroundings. So add those together. So a chemical system, if open, we get an exchange of matter and energy with the surroundings. Okay, if that chemical system is closed, then it is just energy being exchanged with the surroundings. Now, an example of that would be an open soft drink. So, an open bottle of soft drink. We get an exchange of matter because the dissolved carbon dioxide will go out into the atmosphere. Okay, and if it was a cold bottle of soft drink, then energy can flow in from the surroundings to the system, the soft drink, and heat that cold soft drink up. However, put the lid on, then we stop the exchange of carbon dioxide into the atmosphere, and so now the only thing that can happen is the energy can flow in to the system. Okay, so closed chemical systems, only an exchange of energy. Open systems, an exchange of matter and energy. So if we've got that, we've got subject matter 1. Okay, now with our chemical equilibrium, we can have phase changes, and there are some chemical reactions that are reversible. Okay, now if we understand that, we've got subject matter 2. Okay, now we can use, when we write our equation for the process, we have reactants going to products. Whoops, that's a P there. Okay, and we can use arrows to signify that the reaction is going from reactants to products, but also products to reactants. So we can use that arrow, or probably the more common one actually is that arrow. Okay, so we've got that. We're looking at subject matter 3 and also subject matter 4. Okay, now this all occurs at the atomic molecular level. So it is possible that when you're looking at a process that's undergoing chemical equilibrium, that you actually physically see no change. Okay, and that leads to this concept called dynamic equilibrium. So at the atomic molecular level, there's lots of change going on, but at the macroscopic level, there isn't any change going on. Okay, so at dynamic equilibrium, we have the rate of the forward reaction equals the rate of the reverse reaction. Okay, and from that we can then write, all of that is dependent on, that rate is dependent on the activation energy of the reaction. That's subject matter 6, and here the rates we've got subject matter 7. From that we've got the data. Okay, so I'm just going to stop this video here and I'm going to continue the concept map in